Okay, so we're going to use fundamental trig identities.
Oh, we're getting into the good stuff.
Yeah,
Good.
this chapter's a little, this part's a little easier at first, I think, but then section 5.5 is solving equations, so trig equations. So we got to leave enough time for 5.5, whatever we do. Okay, so this stuff is, well, maybe I'll let you just, you should have these memorized. These were the reciprocal identities. You know, the quotient identities. Oh, do you have your test?
Did you get my message on Shelby?
Did I get your what?
Message on Shelby?
No, not yet.
I tried to upload with the Genius Scan thing, but for some reason it won't go from the Genius Scan to Shelby.
Oh,
Yeah,
It doesn't give me the option to upload files from it.
would it give you an option to save it as in your photos and then use those?
I could have done it as individual photos, but you said you wanted it to the Genius
No,
Scan.
the Genius Scan will save it as should save it as a.
I didn't see the option. Again, I feel like if you want it to go directly to your iPad, and rather than having to send it through
Okay.
your email to get it to your iPad somehow, you have to pay about $8 to.
Okay, so you can be filling all this stuff in here. Oh, well, where's your test?
Oh, that's it.
Oh, you're gonna show me.
So we go in here and you would, let's go in your phone, let's go with my pages.
It doesn't show your camera.
What's the starting minutes if you had it?
So you try here, I have it all in here. It won't let me upload it into Shelby. But I have the test with me.
Yeah, just give me the test. I don't know, I haven't worked with that. I thought it would save it in your photos. And then Shelby would give you the option to save. If you hit File in Shelby, it should go straight to that. Okay. All right. Okay, so write all these down. These need to be memorized. If you don't have them memorized already, we've gone over these. So that's being displayed. If you've entered the Nearpod LFVJD, that'll be displayed on your computer. So I'll write them down again for you here, but reciprocal identities. And this is not the right page. So we'll have to look at page 1 over cosecant x. These page numbers aren't going to be right for the new edition. Yeah. 1 over cotangent x. And it is important to write the angle. X is an angle. Don't just write 1 over cosecant and leave the x out. 1 over sine x. 1 over cosine x. Of course, this is 1 over tangent x. And what I say, if you have these memorized, you can figure these out. And I just memorized that sine is 1 over the one that starts with the opposite letter, the C. You know, sine has cosine. Cosine is 1 over the one with the opposite letters. That's how I remember it. The quotient identities are sine x divided by cosine x. That's quotient means divide, so that's why we're writing it like that. Cotangent is the reciprocal of that, cosine x divided by sine x. The Pythagorean identities. This was that quiz I gave you. Sine squared x plus cosine squared x equals 1. 1 plus cotangent squared x equals cosecant squared x, and 1 plus tangent squared x equals secant squared x. Then you got the even and odd identities. Okay, so which of these are even, which are odd? What's the properties? Do you have your test?
Yeah.
I think I have everybody's tests here. Okay, and even odd identities. So if you have the sine function memorized, it looks like this. Sine x. So, and it will continue like this. So sine is it even or odd?
Odd.
It's odd. So sine is odd. So back from Math 1710, an odd function, for an odd function, f of negative x will equal the opposite of f of x. That's the definition. So because these are odd, sine is odd, you got minus sine of x. That's just, we had a minus sign inside, it's an odd function, that's going to equal to the opposite of sine x. I just applied this property to the sine function. Cosine functions even, look. So an even function, but if we graph it, and it keeps going with that, this is cosine x, even. An even function from Math 1710, we f of minus x just equals f of x. So we're going to apply that here. Since cosine is an even function, the cosine of a negative x is just going to equal cosine of x. You can check it out in your calculator, see if the graph looks like that. Tangent. So tangent is odd, so it's minus tangent of x. Cotangent is odd also, so minus cotangent of x. Secant is 1 over cosine, so it's even. So it equals secant x. Cosecant is 1 over sine, so it's odd. So that's minus cosecant x. Those are the even and odd properties. So I have the sine and cosine waves memorized. I have this one memorized, and I can find these from it, and I have all these memorized. You should have that memorized. Okay, so we'll have to use all of these identities here when we're verifying identities. So here's the guidelines. Let's see. We're going to show, to verify an identity, we're going to show that one side that can be simplified so it's identical to the other side. We're going to manipulate each side of the equation independently of the other side of the equation. So we're going to work with each side independently. That's what it says on your notes. We're going to start with the most complicated side and look for ways to apply the fundamental identities that we just review. And these are our techniques we can try. Next slide. Rewrite in terms of sine and cosine. Factor out the greatest common factor. GCF is greatest common factor. Separate a single term quotient into two terms. These are already, there's no blanks here, really. 4. Combine fractional expressions using the lowest common denominator. LCD means lowest common denominator. Multiply the numerator and the denominator by a factor that is on the other side of the identity. Identical to the other side. Identical to the other side. So, let me write that. It doesn't fit. Identical. To the other side. And stop and start over if it's not working. But it's going to take practice. We're going to do a few of these. We're going to verify. There's a times symbol missing and where you see these boxes on the slide. It should be times. Okay. But I'm going to go ahead and work these out. Let's see, we're on 6. Okay. Verify the identity, cosecant x, tangent x equals secant x. So, this is the more complicated side, so I'm going to change the more complicated side to all sine and cosine. So, cosecant is 1 over sine x. Tangent is sine x over cosine x. This is I just changed the left side of the equation. Then we cancel, and we get 1 over cosine x, and that equals secant x. I ran out of room. And so that equals the left side. We've just verified that identity. So we're making new identities. You don't have to memorize these identities, but we're using the basic ones. So rewriting the left side, we got 1 over cosine, which equals secant, and that was the right side of the equation. So we verified, or we can say identity verified. Okay, that's what my check mark meant. Okay, so see if you can do this. Now you got an example here, unless you've printed out the filled-in notes. See, rewrite the left side of this equation in terms of all sine and cosine. So sometimes I probably shouldn't have filled in notes. Okay. It's too easy when you see it already worked. It's like, oh yeah, that makes sense, but you didn't do it. Okay.
I remember this though.
Okay. All right. Well, this is a little bit, I think it's a little easier, but you do need to know your identity and just start working with things. So, we got it. Okay, so did you verify it yet? It should be 2 steps. Right? Sine x times what's secant? 1 over cosine. And we can write sine x over cosine, and that is tangent and that equals tangent x. Verified. So on my building notes, I didn't write this step. I thought it was pretty obvious. So that's a very easy identity to verify. All right. Okay, and we can use a graphing calculator to provide evidence of an identity by graphing each side separately. And looking at the table to compare values separately. Blank there. So we could go into our calculator. So, but we are not verifying the identity, we are providing evidence of an identity when we do this. So we go to y equals, if I want to show that this one's true, clear that out. Sine x, close the parentheses, secant x. Secant, you have to write 1 over, you have to know that that's 1 divided by, maybe I need to do times. 1 divided by cosine. Our calculators don't have secant. Okay, and then you can go to second table. Oh, second table set, make sure it's set up in automatic mode. Let me put the other one in. Just put tangent of x in. Tangent of x. Does it matter what mode we're in here? We're in degree mode, but as long as they're equal, it doesn't really matter. You can look at it then. The table of values matches. That's not how you verify an identity, that's how you can provide evidence. So if I ask you to verify an identity, you need to show it this way. Okay, here's another example. And I'll go to the slideshow for it. Oh, okay, the slideshow. All right. So, verify this identity. Well, number 8. We've got, what I wrote here in my notes was y1 equals the left side, y2 equals the right side. And then you look at your table. Okay, verify cosine x times cotangent x plus sine x equals cosecant x. So I've got, okay, so I rewrote, this is the more complicated side. I started with this. I rewrote everything on this side in terms of sine and cosine. So cosine x stays as cosine x times cotangent is cosine x over sine x plus sine x okay, so I've rewritten it. Well, if, when we have, here, you gotta know how to do fractions. In order to add fractions, we need a common denominator. How do we get a common denominator? What is the LCD? Sine of x. So this already has the LCD. We have to multiply this by what to get the LCD of sine x?
Sin x over sin x.
Right. Sine x over sine x. The LCD, the lowest common denominator, is sine x. In order to add fractions, you've got to know how to add and subtract fractions for this. So cosine x times cosine x, we write it as cosine squared x, plus sine x times sine x is sine squared x. And that's all over sine x. We got a common denominator. We add the numerators and keep the denominator. Now this is the Pythagorean identity, and this equals what? 1. And 1 over sine x is cosecant x. And so that's verified. So we manipulated the more complicated side. So we were using the combined fractional expressions using the least common denominator. That's an example of doing that, and there's more examples in the book. Number 9. We're going to use factoring to verify an identity. So here's 7, 6, 1. Yeah, but I'll work it. That's probably not the right page number. Okay. We're going to factor the sine x from both terms of the more complicated side, the left side. Then we're going to use the Pythagorean identity. So, you got sine x minus sine x cosine squared x equals sine cubed x. You're going to factor out a sine x. What are you left with when you factor a sine x out of sine x?
0.
No. 1. There's an understood 1 here. You can think of dividing by sine x if you need to. If you divide by sine x, the factoring out process, you could think of dividing that out and just putting it out here. See, this divided by sine x would be 1, so we're just changing the look of it by factoring that out. So no, don't make that mistake that it's 0. But that's why I tried to ask, because a lot of people think it's 0. And then you get minus cosine squared x equals sine cubed x. All right. Well, look, I'm going to write up here the Pythagorean identity up here. Sine squared x plus cosine squared x equals 1. If we solve for sine squared, we're going to subtract cosine squared x. So we had to manipulate this identity, and you have sine squared x equals 1 minus cosine squared x. So 1 minus cosine squared x equals sine, so we have sine x times sine squared x. Okay, so that's sine cubed x, and that does equal sine cubed x. Verified. Okay, so it does require you to remember your algebra here. All right, the next one is B. Okay, see if you can do 9B. It's very similar. The first step, let's see. 9B, can you see anything you can factor out? Factor it out. Then manipulate your Pythagorean identity. So I'm waiting to give you time to see if you can work this one. So then you bring it here. You should have your notebook paper out trying to do that. Just as you do that, so the notes you should just sit there. So factor out the secant x. Okay, you went ahead and rewrote it as that, then you're going to factor out the 1 over cosine x.
That's what I'm thinking.
Yeah.
I didn't know if that was a.
It may be easier to factor the secant x
For me,
out.
it's just easier to like use the 3 basic ones. You know?
Oh, that's fine too. You can do it that way. Yeah, you can use the steps in different orders. You got his all in terms of sine and cosine. I went ahead and factored the secant out first, and then wrote it as in terms of cosine.
So, would I divide?
Well, you have to divide. When you factor this out of this, you're going to be left with 1.
Okay.
Just remember that it's not 0. This, you have to divide by this whole thing.
And then you did it, and then I
And
can.
then you get this. Yeah?
Okay.
And I don't usually write that step where it might be easier to factor the secant first. Just gets. Okay, so I factored the secant out first. 1 minus sine squared x equals cosine x. Oh, I didn't need to write that each time. Just write the left side. Well, 1 minus sine squared equals cosine squared. You can do that. Cosine squared x plus sine squared x equals 1. This is the Pythagorean identity. You want to find 1 minus sine squared cosine squared x equals 1 minus sine squared. So this is, and secant is 1 over cosine x, and that is cosine squared x, and then one of the cosines cancels, and you get cosine x. Okay? So what happens if you don't remember your algebra or your identities? You can remember those things. Okay. That's one way. You could have changed it all in terms of cosine and sine first, but Any questions? All right. Using two techniques. There's two techniques to verifying an identity. Okay. All right. This is number 10. I guess I must have given myself more room on this paper. All right. Oh, there's a typo on here. Oh, I just rewrote it. It's divided. This was just messy problems with the word processor. Yeah. Verify this identity. Remember, if you have a fraction, you can separate it. So I'll write that over on the side. If you have A plus B over C, then you can separate that as A over C plus B over C. And that's what I'm going to do on the left side here. So what am I using? I'm using the separate a single term quotient into two terms, but I didn't write this down for you. A plus, but I did just now. So A plus B over C equals A over C plus B over C. And you can see the filled-in notes. That's the first step. The filled-in notes didn't have as much room. So we're going to separate this as 1 over sine x plus cosine x over sine x. And what is 1 over, it's kind of using two identities here. Well, yeah, now I'm using the fact that 1 over sine of x equals cosecant x. And cosine x over sine x is cotangent x. And so that equals the right side verified. Okay. Is this making sense? What's this? Is this a picture? Oh, I put a picture in here for a break. A 3D picture just for a brain break. Especially after doing that take-home test, yeah. Yeah. So, I don't remember what this is. This is in Italy, the Vatican. What's this, Vatican?
Vatican?
Yeah, I'm thinking. The Nearpod program has all these 3D pictures in it that lets me just pick one. It's pretty cool. So this is the Vatican. Okay. Are you done playing with that? Okay. Oh, sorry. Did you like it? You like those 3D pictures? Okay. All right, back to verifying identities. Okay. We're going to combine fractional expressions to verify an identity. All right. Okay, so this is sine x over 1 plus cosine x plus 1 plus cosine x over sine x equals 2 cosecant x. So, what's the LCD?
Sine x, 1. Oh, 1 plus cosine x.
The LCD is sine x times 1 plus cosine x. That's always a common denominator to multiply the denominators. In this case, there's no common factor, so that's the LCD. So to save space, I went ahead and wrote on my paper. So you would multiply this fraction by 1 plus cosine x, and this on both top and bottom. Then you multiply this one, is missing the sine x, so you multiply by sine x over sine x. Okay, so we get sine squared x, and what did I'll just write it as 1 plus cosine x times 1 plus cosine x, which I will need to FOIL. All divided by the common denominator. Sine x times 1 plus cosine x. Now don't start separate it and start canceling. The point was we were going to put it together. We began by finding a least common denominator. Now we put it together. We're going to FOIL this. So we have sine squared x plus, 1 times 1 is 1. The outer term is plus cosine x. The inner term is plus cosine x. And the last term is cosine squared x. Remember, that's how we write cosine squared. And it's a plus sign, so we don't really need the parentheses. All right, and then that's all divided by the common denominator. Okay, so we have sine squared x plus cosine squared x. That equals 1. So we're going to replace that with 1. So we get 1 plus 1, and we have 2 cosine x's plus 2 cosine x. All divided by sine x times 1 plus cosine x. It looks like I didn't finish it on my notes. Okay. Add this together. This is 2. Factor the 2 out. Factor the 2 out. Remember, you're left with 1 plus cosine x. And that's divided by sine x.
What happens to the other two? Because we have 2 plus 2 cosine x?
Yeah, we had 2 plus 2 cosine x.
Oh, I see now.
2 plus 2 cosine x, we factored the 2 out. Divide this by 2, you get 1. Divide this by 2, you get cosine x.
I see.
So I kind of skipped a step there, but... and then... Oh, wait a minute. I need to write this down. And then cancel it. Okay. That's the common denominator. These are the same factors. We cancel factors. So we cancel that. So now we're left with 2 over sine x. Sine is cosecant. So we have 2 cosecant can't write x. Okay, and that equals the right side. Aha, so the filled in notes, we're missing those steps, right? Or were they? I don't know. On my notes here, I'm missing those steps. Okay, any questions? So you had to find a common denominator, you had to FOIL with trig functions, you had to combine your like terms, factor out a 2, cancel, and then use that last identity that 1 over sine x is cosecant x. Okay. That was, okay. We used, so the steps are here on the slideshow too. The least common denominator, they added them, FOILed it. They added the numerators. We put this sum over the LCD. And sine squared x plus cosine squared x was 1. Add the 1 plus the 1 is 2. But you can't add the 2 plus the 2 here because the 2 is multiplied by cosine. Don't write that as 4 cosine x. You really need to know your rules of algebra. You have to have like terms to add, so this is not 4 cosine x. And then you factor the 2 out. And these slides are all posted in Shobi too, so you want to refer to them there. Cancel, and cosecant x is 1 over sine x, and we get the right side of the equation and identity is verified. So the slides actually do a better job of writing down exactly each step here. All right, let's see, do we have we have another one to do. Oh, what fun. So those are the beginning steps. So we're almost done with this. And we can spend some time. I probably have a worksheet for you to do, right? I'm just nice like that. Number 12, let's work through this one. Sometimes you may need to work with both sides separately to verify identities. So we're going to begin with the left side. So the left side is 1 over 1 plus sine x and 1 over 1 minus sine x. What's the least common denominator there? We're going to just multiply these. So I'm going to start with the left side. We're wanting, if they're separate, you need to find the least common denominator. So it's going to be 1 times, these two multiplied together would be our LCD. 1 plus sine theta, 1 minus sine theta. So this one is missing the 1 minus, so we need to multiply by that. 1 plus sine, 1 minus sine theta. This fraction is missing the 1 plus, so we multiply by 1 plus sine theta. So this is the left side. We're going to combine our terms now. We keep our common denominator. 1 minus sine theta plus 1 plus sine theta. That's the top of the fraction. the bottom of the fraction, you're going to actually FOIL this. 1 plus something and 1 minus the same thing. What do you get? It's a difference of perfect squares. You can FOIL it out, but you get 1 minus sine squared theta. It's the difference of perfect squares, always, or FOIL it. The middle terms are going to cancel. The first term is 1, the last term is minus sine squared theta. It's the difference of perfect squares. A plus B, A minus B, always multiplies to A squared minus B squared. That's, or you FOIL it out and cancel your middle terms. Okay? At this point, you probably want to have some of these things from algebra memorized so you can skip some of these tedious steps. Okay, and then add the 1 plus the 1 to get 2, and the sine theta plus minus sine plus sine, we get 2 over 1 minus sine squared theta. Which, by the Pythagorean identity, we used this already, is 2 over cosine squared theta. Okay, so that's the left side. We got the left side. We're going to do the right side. So I got the left side to 2 over cosine squared theta. And I didn't write all my, we added the numerators, put the sum over the LCD, simplified the numerator, we multiplied the factors in the denominator. We, okay, did they stop there? Okay, well I kept going. You could keep going or stop. All right, now we're going to work with the right side. That's the left side. To give me some room, I'm going to say right side. 2 plus 2 tangent squared theta. So factor of 2 out, 1 plus tangent squared theta. This reminds me of a Pythagorean identity. Or, oh, I could just go ahead and it is just secant squared theta. Or, so if you see that, you can use that one. Or you can write everything in terms of sine and cosine, because I have the cosine squared theta plus sine squared theta equals 1. Memorize, I have to look back at the other one. So on my filled-in notes, maybe I changed it to sine and cosine. But, but the identity from page 1 was 1 plus tangent squared theta equals secant squared theta. So let's just do it that way. So we get 2 times secant squared theta, and that's actually easier. And secant squared is 1 over cosine squared. So 2 over cosine squared theta. Verify. We got the left side equals the right side.
That is much easier than the filled-in notes.
Yes. Yes, that is easier. I had to do a lot of manipulations when I changed the sine squared theta over cosine squared theta. Yeah, this was much easier. Okay. So, yeah, there's many different ways, and you can go around in circles, and you can get back to your original thing, and have no idea why. Okay. So, you're trying to reach a common goal, and have your identities in front of you, and be looking at them. That was a perfect identity to use there. And that's not how how did, you guys, you still ready?
Yeah, give me just.
All right, but on the slideshow, they solved it a little different. They left it, the slideshow left it this way on the left side, and then they got the right side to look like this. So we'd have one more step to make that look like that. Okay, so the slideshow worked with the left side. Oh, this is, okay. Now they're working with the right side. They did make it more complicated, I think, by changing tangent theta and tangent squared theta, changing it. So they made it more complicated. It still works. You factor the 2 out, and this is 1, so you get 2 over cosine squared. So you get your choice. There's no one right answer on these things. See, they were making it look like this. I found it was easier to make it look like 2 over cosine squared. All right. Is this the same one, or is it a similar one? Oh, okay. Is this? That's the same one we just did. I don't know how we got duplicate slides.
Well, one's tangent and the other's cotangent. Right? Example B has...
Oh, yeah, but this is the example A still. Okay, here's example B. Okay, so this is similar, so I didn't do it in the filled-in notes. Verify the identity. So if you want to try it, it's exactly, you do the same steps, and I think if we take our shortcut, this one's going to end up using it, one of those, we use a shortcut on it. So you work on the left side, multiply through by the LCD, and there's not enough space for it here, really. Foil the LCD out, combine your like terms, factor the 2 out, I assume you're doing it, but so you multiply by 1 plus cosine theta and 1 minus cosine theta so you have 1 minus cosine theta plus 1 plus cosine theta over the common denominator, which is we FOIL that out, we get 1 minus cosine squared theta. And then this equals 2. And 1 minus cosine squared is sine squared theta. So that's the left side. Now work with the right side. Yeah. We're going to do the same trick we did on the last one, the right side. Just factor the 2 out, 1 plus cotangent squared theta. Look at our Pythagorean identities. 1 plus cotangent squared theta is cosecant squared theta. And that's 2 over sine squared theta. So that was quite a shortcut to know those other identities. And not always put it in terms of sine and cosine. And so, but sometimes none of the suggestions for verifying the identities work. In this case, you can try working with one side and trying to make it look like the other side. So the next one, we're going to multiply. This is number 13. You're going to, because you have a 1 minus sine x up here in the numerator, you may multiply the numerator and denominator of the left side by 1 minus sine x. So I'm starting with the left side, cosine x,
Or this just,
left,
they're like the same. Oh, I see, one's possible.
okay. And then I would go ahead. I don't distribute this because I'm going to multiply the numerator here, and I'm going to get cosine x. I'm going to not multiply the numerator. I'm going to multiply the denominator. It's if you FOIL it, the middle terms cancel. So you get 1 minus sine squared x, which equals cosine squared x. And so we cancel one of the cosines. So we get 1 minus sine x over cosine x. Verified. So the trick is to know, let's try multiplying this side by 1 minus sine x to try to get this numerator. And then it did cancel, and that's what we got. So, and then we can change sines and cosines to verify an identity. Okay. Let me switch the slideshow to. Okay, that's the next one. Number 14. Oh, I'm working on the blank page on that. That's where I work 14.
Can we like try this one and then do it together?
Yeah. You can try this one. Try to change everything to sine and cosine. And this is the last one. 1, 2. And what do you have in Shelby that's due? All right. Oh, so this won't be due till next week. So you don't have anything due on Thursday, right? So we won't worry about it right now. So this is why I had the blank page. There's not room to work with. Rewrite everything in terms of sine and cosine. I'm starting with the left side. Secant is 1 over cosine x. Oh, use the properties. what's cosine of negative, cosecant of negative?
Negative cosecant x.
Right.
Or 1.
Or negative, minus 1 over sine.
Oh, yeah, so then it's gonna be minus 1 over sine x. You can't have, the angles have to be the same. Have to get them all in terms of x and not have any negatives in there. Okay, so that was the numerator. The denominator is secant x, which is 1 over cosine, and cosecant 1 over sine. So our common, I want to multiply, what I did is, I'll write it in. I want to get rid of this numerator. You could flip it and multiply, or I multiplied by sine x times cosine x. You could flip it and multiply also over 1. So that cancels here. And now I want to distribute this times these things. So let me just write what we're left with. Sine x cosine x times 1 over cosine x minus 1 over sine x. We're then going to distribute that. I can write it out. Sometimes I skip these steps. 1 over cosine x minus sine x cosine x times 1 over sine x. These cancel. And then you're left with sine x over cosine x. Oh, sine x, sorry. Cosine's gone. Minus cosine x. Is that the right side?
Yeah.
Yeah. So, verified. So you would write it as verified. Write at least verified next to it. Once you get one side equals, the left side equals the right side. So that's, so if you go, are you confused on this step? You could flip this and multiply. Same thing. Flip this and multiply is the same as what I did. I just left it. It was a fraction within a fraction, so I multiplied both top and bottom by that. Whatever, I wanted to get rid of this. But, all right, so that's it. Any questions? That's 5-1. And I will be grading your test. Nobody else came in late?